Okay, your green is motors. So you have 8 different motors. These purple boxes are generators. They're giant generators. They could be AC or DC depending on what project I'm talking about. I'll explain. They're 100 feet by 100 feet, which makes the radius of the generator 50 feet. The red shading is a stator external circuit, which is where the power is produced. These generators are alternator and stator copper external circuit. Okay, so here is your cylindrical commutator. Um, you have your negative contact, which is 1, which is copper. It's a copper tubing, which number 2, your dielectric separates any rubbing contact from the negative 1 contact from the third positive contact layer. It's a third layer, but it's the positive contact, which is just copper tubing, which fits the dielectric. So you have 3 layers, and it's a cylindrical object. Here's the side view of your commutator. Okay, now this commutator is a little bit more advanced. It's just showing many layers inside of, it's not cylindrical anymore, but it does have a cylindrical outside or base. You have 7 layers. 1 is your negative contact. Your negative contacts are in blue, your positive contacts are in orange, and your dielectric layers are in pencil. So you have 1, which is your negative contact, which is furthermost to the radius of the commutator. And it's also on the right side furthest furthest right. So it has a reach far right. Then you have 2, your second layer, which is a dielectric, which separates rubbing contact from the third layer, which is your second negative contact. So here is your second negative contact, and it is a little bit shorter in base length than the first negative contact for contact rubbing reasons when you hook it up to a source. Power source. So you have your fourth layer, which is another dielectric to separate the third negative contact from the fifth positive contact. As you notice, each contact layer does not touch another contact layer. So no contact layer touches another contact layer in rubbing contact except through an external circuit. So 6 is your dielectric layer, which separates positive contact layers 5 and 7. So I'm going to explain in the diagram now. So you have 1 negative, then you have your second layer dielectric, then you have your second negative contact, which is your third layer, then you have your fourth dielectric layer, then you have your fifth positive contact layer, you have your sixth dielectric layer, and you have your seventh positive contact layer right here. So 7, 6 dielectric, 5, 4 dielectric, 3 negative, 2 dielectric, and 1 negative. So now what I'm trying to explain is this is going to be hooked up to a DC generator. It's not a simplified generator. Here are your coils. This is an armature external circuit, but there's not just one external circuit, there are many external circuits. So you have 1, 2, 3, 4, 5, even the inside, every copper circle is another external circuit, and it's its own external circuit and does not cooperate or have any energy sharing, I'll just say, to any of the other circuits. Every circuit is single and closed. So as you see all kinds of leads from all these external circuits to this is a giant DC generator. It's I put 1,000 feet by 1,000 feet, so your radius would be 500 feet. Your radius would be here, and you have all these negative leads to the center of this generator. Okay, so this is where this commutator comes in place. This is only a 2-circuit commutator. So you have 2 external circuits here. Your first external circuit, one end lead touches the 5th layer, end of the positive contact, and the other lead touches the first layer of the negative contact. So you notice that the only way the contact layers of the first contact and the fifth contact is through the external circuit right here, which is just a copper coil. Okay, and also the seventh positive contact is touched by one end and also soldered or placed with the commutator as the commutator moves with the external circuit. So one lead of this second external circuit touches the seventh positive contact and the third negative contact. All the touching leads are on the left side of the commutator. So the left side of the commutator and the external circuits are the moving parts of the generator so far. Then you have your output, or you could reverse it and make it a motor. But we'll talk about this as being a generator first. So you have, I'll write this down in red. You would have a brush here for your third contact, a brush here, a brushing contact for your first contact, a brush here for your positive fifth contact, and a brush here for your positive seventh contact. So each of these brushes just rub against the moving commutator as the commutator moves. And notice all the layers are separated by dielectrics, so the only way that the electricity can flow is through the external circuit. So now you could understand how a commutator can be placed, my advanced commutator can be placed into the center of this DC generator. And notice it's a new art form. So basically you need a much more layered commutator to fit all these copper external circuits, because every external circuit, remember, has its own external circuit. So why would this be used? So if you think about it, if you were to make a very large power source which